Oh, okay. So let's do a little formal definition. So let's say, for example, we want to prove that the limit as x approaches. Do you guys want to do a quadratic? Would that be a good one? Limit as x approaches, say 2 of x squared plus 4x minus 3 is equal to, what is that? What is it? 9? 4 plus, oh yeah, 9. Okay. All right, so kind of gave you guys a blueprint, right, to sort of how to approach it. So the first thing we kind of start off with is kind of doing some scratch work, right? We kind of set it up, right? So we say, okay, well, what are we trying to show? We're trying to show that f of x minus L is less than epsilon, right? Okay, so f of x, which is my function, minus L, which is the value of the limit, right? So I'm trying to show that x squared plus 4x minus 3 minus 9 is less than epsilon, right? And what is epsilon? So epsilon, we kind of, when we're going through this, we think of epsilon as being just a small number. So like, think of it as being like really small, like 0.0001, let's say, you know. So then what's the next step? Do a little algebra on this, right? So you simplify it a little bit. And so, okay, so let's do that. So let's see here. Okay, so let's write it down. So we have x squared plus 4x minus 12, right? If we add the minus 3 and the minus 9. So what is that equal to? So it depends on the function, but it's a quadratic, so probably factor, right? Okay. So what does this factor into? Plus 6 and then x minus 2. So this is because it's a quadratic. If it was, say, for example, it was a fraction, what would you do? Probably combine them into a single fraction. If you have radicals, probably you're going to, starts with an R, ends with an E, rationalize. Yeah, so it just depends on the kind of function, what kind of algebra you do. So if it's a quadratic, you factor. If it's a fraction, you combine them. If it's a radical, rationalize, probably. Okay, now, here we look at these, right? And which one's the one that I control? Which one's the one that x minus 2, right? So here, this one right here. So I know that from the definition, x minus 2, and where does 2 come from? It's right here, right? X minus, what we called it, C or A? It doesn't matter, but I think we called it C, maybe? I think. But I know that x minus c is going to be less than delta, and I can set delta to be whatever I want, right? Okay, so I don't worry about this one because I can make this as small as I want, x minus 2. But I need to do a little bit of work to bound this other guy, this x plus 6 business, right? So if you remember our strategy, this is kind of our strategy. We go, okay, since we know this right here, we know that x minus 2 is less than delta. Let's suppose that delta is less than something. So give a number. 1. So 1 is nice because it's a nice, easy number to work with, right? We could have said 10. We could have said a half. We could have said 0.1. But we pick 1 because 1 is easy to work with, and we're going to do a little algebra. Yeah? So far, so good? Okay. So what can we say? Well, since we know this right here, right? Then if delta is less than 1, then what do I know about x minus 2? Okay. So then x minus 2 in absolute value is less than 1, right? Does that make sense? Okay. So what does that mean? Well, that means that, yep, x minus 2 is between 1 and minus 1, right? So where does that come from? How can I go from how can I take that step? What allows me to do that? That's just the definition of absolute value, right? So x minus 2 being less than 1 in absolute value, what does that mean? That means that it has to be between minus 1 and plus 1, right? You can't go outside of that range of values. Does that make sense? Okay. Now, what is it that I'm trying to bound? I'm trying to bound this guy right here, the x plus 6, right? So then what do you do? Well, you want this right here to be x plus 6, basically. This is kind of what you're trying to get to. So how do you get from the red to the green? How do you get from x minus 2 to x plus 6? Add 8, right? Okay, so you add 8. Let's see, what would be a good color? I'll just do this one. So if I add 8 to everything here, what do I get? That x plus 6 is going to be between 7 and 9. Okay, and then this, so let me just rewrite it here so that we have it over here again. Okay, so from this, what can I say about the absolute value of x plus 6? What is for sure guaranteed it's going to be less than? 9, right? So you pick the largest of the two in absolute value, and that's what you say it's going to be less than. So now, what is all of this based on? All this this chain of logic that we just said. It's all based off of delta being less than 1, right? Okay, so do we have any questions up to that point? Does that make sense? Okay. Now, so based off of that, so now if we kind of go back here, so this is kind of what we're looking at here, right? So if I just kind of write this down, x squared plus 4x minus 12, which is equal to x plus 6 times x minus 2. So if I use this that I just found right here, what can I say that this is going to be less than? If I know that x plus 6 is less than 9, then x plus 6 times x minus 2 is going to be less than 9 times x minus 2. This is just a substitution. That's all it is, right? This x plus 6 is less than 9. So far, so good? Okay. What can we now say then? What is it about delta that now that we know that, so what we were trying to show that it was less than epsilon, right? Which is this x squared plus 4x minus 12. We now know is going to be less than 9 times x minus 2. So then what is delta going to be less than? We want it to be what? Almost epsilon over 9, or the smaller of epsilon over 9, or 1, right? Because, for example, I mean, not that you would ever do this, but let's just say, well, what if epsilon is 100? Which is a bit silly, but if epsilon is 100, well, 100 divided by 9, that's about 10. But you had already said earlier that delta was going to be less than 1, so you're kind of contradicting yourself. So that's why you say delta is going to be less than, so let me see if I can fit it in here, the smaller, the minimum of 1 and epsilon over 9. Would it be okay to say that delta is equal to the smaller of of 1 and epsilon over 9? Is that the same thing? It's not the same thing, but it's equally valid. Why? Because in the definition, x minus 2 is strictly less than delta. So if you make delta equal to or less than, it doesn't matter. Either one is fine. Yes?
I don't have problems.
Yes?
With that.
Yes, this is normal because how many of you guys have taken a class on proof writing? Nobody's taken a class in proof writing. That's silliness. So you take it when you take discrete math. That's where you technically learn how to write proofs a little bit. But it's a skill. It's like anything, you know. So it's not like magic that you just should know how to write proofs. It just does not work like that, you know. Nobody's born knowing how to do anything, really. It's like my baby. She can't do anything. Can't even hold her head up, you know. And I mean, really, just hold it up. I'm just kidding. But okay, all right, so let's use that to write down the proof. So what I would recommend, what I suggest, is just use the template that I gave you and just treat it like a fill in the blank. And then as you practice more, it'll just get a little bit easier over time. Yeah. So, you know, don't feel bad if you don't just magically know how to write proofs all of a sudden. You know, it's just not normal. Okay, so how do we start it? So let's say let epsilon be greater than 0, right? Or given any epsilon greater than 0. What about delta? Okay, well then, okay, so if we're going to put it there, then I think that sounds funny. Let's say given any epsilon greater than 0, let delta be the smaller of 1 and epsilon over 9. So I don't know if this is exactly the way that I gave you, but it's important to understand that epsilon can be any number, and delta, there just has to exist 1 for that epsilon. So it's like you're given epsilon, you have to come up with a delta. If you're given a different epsilon, you have to come up with a different delta. You know, so it's like this back and forth, like we talked about. So you're given some epsilon, and you're saying that delta is going to be epsilon over 9, basically. So then what do I do? Well, so I write down, what was it, x squared plus or minus 4x? I forget. Plus 4x. Minus 12, was it? Okay, minus 12. And you don't have to write down all of the scratch work, just the basics. So this is equal to, what was it? Did we do x plus 6 first, right? X minus 2. Okay, this is less than 9 times x minus 2. Now, if you just come up with this 9 out of nowhere, well, I'm going to be like, well, that, you know, how did you know that? But we have it over here, right, in the scratch work. So, you know, for grading purposes, I can see your scratch work and I know where the number 9 came from. If you're writing this down as a math person, then this 9, it's like, oh, well, yeah, obviously it's less than 9. I mean, come on, you know, that kind of thing. So for me, you know, I can see, oh, yeah, that's where the 9 came from. It's right here. You know, I can see the chain of logic that you used to come up with that number 9. Does that make sense? But if you don't have the scratch work and you just put down a 9 there, then this is not okay. Does that make sense? Okay. Okay, so this is less than 9 times x minus 2, which is 9 times epsilon over 9, which is epsilon. And that's it. And then you can put your little square, and then, or whatever you want to do, you can put a smiley face. So, you know, really it's most of it is in the scratch work, most of the actual work that you need to do. And then when you're writing the proof, I mean, really it's just just kind of restating. And then it's probably a good idea to, restate what it is that you're trying to prove. Thus, the limit as x approaches 2 of x squared plus 4x minus, what was it again? Minus 3? Minus 3 equals 2. 9. Okay, something like that. So I know it's kind of weird. I think, what do you gain from this? I think maybe you get a little bit of the behind-the-scenes look at what kind of goes on in calculus. So like where you would see this would be in like if you took advanced calculus or real analysis, where you kind of go really underneath with what's going on with calculus. Whereas here it's more like we're using calculus. We see a little bit of what goes on underneath, but when you take advanced calculus, then you really go down in there, see how everything works. So there's a lot of epsilons there and deltas and cool stuff like that. Any questions with that? Yes.
What counts as advanced calculus?
Well, it's like how when we started studying limits, for example, I kind of gave you this definition and like, well, don't even worry about it because it doesn't make any sense. Let's just like start calculating some things, and then I explain why things are the way they are, but it's basically you guys trusting me that I know what I'm talking about. I'm not really 100% showing you absolutely how every single thing follows from what I just told you before. So advanced calculus is like it's like you build calculus, all the ideas from the ground up, like from really, really, really basic stuff, and like epsilons and deltas, and you just start proving all the theorems. And so it's like going back through this class, but proving absolutely everything. That's really fun, but it's harder, But that's normal, But yeah, it's good times, It's good times. It's an acquired taste. It's like, how many of you guys like beer? Beer, right? But how many of you guys like beer from the first time you tried it? Say. But it's an acquired taste. So proofs are kind of like that. It's an acquired taste. Okay.